Hey there, fourth graders. This is Mrs. Smith here. Today we are doing Unit 3, Lesson number 6, which is on page 117 of your book. So go ahead and grab that. You're probably also going to want your whiteboard, so grab that too, and your marker. All right, you ready? So in this little lesson activity today, we're going to practice our division. You can use whatever method you like. I'll mix it up and do a couple different ones. Then we're going to solve some word problems. You're going to have to think about how to set up that division problem on your own, and then thinking about division in the practical sense. So if, like, these are some scenarios of, like, packaging notebooks and stuff, and, you know, you have to think about, like, how many things would be left over, how many, like if you have things left over and you need to contain them in something, then how many containers do you really need to buy? That sort of thing. So let's go ahead and get started. I'm going to start with the digit by digit method for number 1. So how many 8s can go into 9? 1, right? 1 times 8 is 8. Subtract 1. Bring that 6 down. 6. Now we have 16. 8 can go into 16 how many times? 2. 8 times 2 is 16. Difference is 0. Bring down that 0. 8 goes into 0 times. Okay? 120. Nice job. Next one. Here we go. 4 can go into 6 how many times? 1. 1 times 4 is 4. Subtract. You get 2. Bring that 3 on down. Now we have 23. 4 can go into 23 5 times, right? 4 times 5 is 20. Subtract 3. Bring that 2 on down. 2. 4 goes into 32 how many times? 8. I'm feeling very cramped with this amount of space. So I think for these two, I'll keep going with this method, but then if I'm going to do the different methods, I'll use my whiteboard for that. Okay, 7 can go into 800 how many times? Well, how many hundreds, right? So it would be 100. The 1 there. 7 times 1 is 7. Subtract. Difference is 1. Now we have 10 tens. How many tens do you multiply by 7 to get 100? Well, 1, 7 tens, and then you subtract 3, and then you have 9 brought down. 7 goes into 39 how many times? 7 times 5 is 35, and then we subtract, and we have 4, a remainder of 4. All right, next one. 5 can go into 7 how many times? Just once, right? 2 would be 10, and that's too many. So 5 times 1 is 5. Subtract. If 2 is the difference, bring down that 3. 5 times what gets you close to but not over 23? 4, and that'll be 20. Subtract 3. 6 comes down. 5 times what gets you close to but not over 36? 7, which will get you 35, and then you have 1 left over, so remainder 1. All right, as you can see, all of these, it's like, I'm trying to write pretty small, but I'm running out of space. So I'm gonna get my whiteboard marker, and while we're at it, we might as well try one of the different methods. So let's do this one in the expanded notation method. Setting it up, 3068 divided by 4. So that over there. There we go. So 4 can go into 3, like, if you had 4 boxes and you have 3,000 of the things to put in the boxes, can you put a full 1,000 in each box and have one, have all the containers have something in them? No, right? You could have a full 1,000 in 3 boxes, and then 1 box would be empty. So then we look at our hundreds. Now we ask ourselves, okay, if we have 4 boxes and 30 hundreds, Could we put a full 100 in each? Yeah, we could put like definitely a full 100 in each. You could put several full hundreds in each. So we'll say 4 times what? 4 times how many hundreds gets you close to but not over 30 hundreds? 700 will get us 2800, right? So then we'll subtract, ungroup right here. It's been a while, hasn't it, since we've ungrouped? Okay. Now we have 268. How many tens would you multiply by 4 to get close to but not over 268, or 26 tens? I know that 6 times 4 is 24, so 6 tens will be 24. Tens, 240. 8, 2. Okay, and then there's that 28 again. What times 4 gets you 28? 7. No remainder. So we'll write that down. 760 and 7, also known as 767. And I almost accidentally wrote it right above that 3, but why would that be wrong? Do you know? Because that would be saying that there's 7 in the thousands place, and there's not 7 in the thousands place. There's 7 in the hundreds place, and in the ones place, but certainly not in the thousands. All right, let's erase that. Whoops. And try the next one. We'll do the expanded notation method for this one too. 6,206 divided by 3. Okay, how many thousands would you multiply by 3 to get close to but not over 6,000? Well, you could do 2,000, right? And that would get you 6,000. Now we'll subtract. Okay, and then from there, how many hundreds would you multiply by 3 to get close to but not over 200? Well, even if you did 100, it's going to be too big, right? So let's say 0 hundreds. So you're subtracting nothing and you still have 206. Okay, now tens. How many tens would you multiply by 3 to get close to but not over 20 tens? So let's see. 5 would be 15 tens. Can we go closer? I think so. 6 would be 18 tens. That's really close, but 7 would be 21 tens, and that's too high. We only want 20 tens. So we'll do 6 tens. We'll get 18 tens. Ungrouping again. Now we have 26. What can you multiply by 3 to get close to but not over 26? Well, you can do 3 times 8, and that's 24, right? And then you have 2 as the difference. So this is 2,068, remainder 2. Yep. And we'll write that down on our paper. Look at all that math. Whew. So now we are putting that in the thousands place. 2,000, 0 hundreds, 6 tens, 8 ones, remainder 2. All right, now we'll do one of the place value sections just for fun. I'm going to draw my rectangle. Now I'm going to have a thousands box because I'm looking here and I'm noticing, can you have 2 times the number of thousands and get 6 close to but not over 6,000? Yeah, you can do 2 times 3,000, right? So I'm going to have thousands here. So I'm going to put my 2 over here. My 6,476 right there. And then here, like I just said, I'm going to put 3,000. And then I'll multiply 2 by 3,000 and I'll get 6,000. And then I'll find that difference, 476, and I'll bring it into my hundreds box right there. Now I have 476. What can I multiply? What 100 can I multiply by 2 to get close to but not over 476? I could do 200, and that would get me 400. Subtract 6, 7, bring that over my tens. 76. Okay, now what can I multiply? What 10 can I multiply to get close to but not over 7 tens? Well, if I did 3 tens, then I'll get 60. If I did 4 tens, I get 80, and that's too high. Find the difference. 16. Bring that 16 over here. What 1 can I multiply by 2 to get close to but not over 16? 8, right? And then I'll get 16 with no remainder. So 3,238. Okay, now let's do one more of these. Here we go. How about you try a place value section model on this one? And then fill it out with me, like correct it with me, okay? Okay, so go ahead, pause, give it a shot, and then play when you're ready. 8,825 goes there. I can multiply 6 by 1,000, and I'll have 6,000. Subtract that. 5,282. Bring that over to my hundreds. 825. What 100 can I multiply? I'll do 400. And that'll get me 2,400. Find the difference. 5, 2, 4. Bring that into my tens. 400. Okay. How many tens can I multiply by 6 to get close to but not over 425? If I do 7 tens, get 42 tens. Then I just have 5 left over. And then bring that 5 into the ones place. How many ones can I multiply 6 by to get 5? Close to but not over 5. Like really, if I do 1, it's over it. So I have to do 0. And then 6 times 0 is 0. So our remainder is 5. So 1,470, remainder 5. 1,470, remainder 5. All right. Hopefully by now you're getting the swing of this thing. Okay, now we're going to talk about these word problems. So word problems are intended to help kids understand that math isn't just numbers on a page. Math is something that you use if you're running a business or if you're baking things, or really like in many, many, many areas of life. You have to be able to understand how to put numbers together to find a solution to your problem. So here we go. A helper in the school store suggests selling notebooks in packages of 4. How many packages of 4 can be made from 192 notebooks? What do you think we should do here? Would it be 4 plus 192? 192 minus 4? 192 minus 4 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 until we're down to 0? 192 times 4? 4 divided by 192? What do you think? Well, if you have 4 packages of something, and you have a certain number of packages, we'll put P for packages, that's equal groups, right? all the packages have 4, and you're just trying to figure out the number of packages. And if you multiply those together, we want to see if you can get 192. So what we're going to do is we're going to do 192 divided by 4 to get the number of packages. Okay? So let's go ahead and do that. Let me write that a little bit neater over here. Can 4 be multiplied by a whole number and be not bigger than 1? No, 4 times 1 is 4, and that's too big. So we'll go over to this place, and we'll look at our 19 tens, I guess. 4 times what gets us close to, but not over 19? About 4. So you could think of it as 4 tens, right? So then we'll have 16. We're doing our digit by digit method now. And then we'll subtract and find the difference, 32, or 3, and then bring down that 2. And then we'll have 8, right? Because 4 times 8 was 32. And there's no remainder, which is lovely. So that would be probably a good number to package them in. So we'll write 192 divided by 4 equals 48 packages. Okay. A good idea, helper. But let's see. Another helper suggests selling notebooks in packages of 6. How many packages of 6 can be made from 192 notebooks? So then we'll have our number of notebooks that is being divided, right, our dividend, now divided by the divisor of 6. Now, do you think this number is going to be bigger or smaller than 48? If the group number is, the number in each group is bigger, that means each package is going to have more. So then, do you think you're going to have more packages or fewer packages? Probably fewer, right? That would make sense. Because if this number was also bigger, then this number would have to be bigger too. Okay. 6 goes into 1. Well, it can't really go into 1. You can't have 6 times a whole number and get anything smaller than 6. So we'll go over here to our 19. 6 times 3 is 18. And then we have our subtraction. And then 6 times 2 is 12. Also no remainders. So they would have fewer packages. They'd have 32 packages. So we'll do 192 divided by 6 equals 32 packages. Okay, now the question, 2 parts here. The store will sell packages of notebooks for $3 each. Which would be a better deal for students, the package of 4 or the package of 6? What do you think? If you're spending $3 either way, would it be a better deal for you to have 4 notebooks or 6 notebooks? 6, right? That's more notebooks for the same amount of money. Now, which package size would make more money for the store? If you're selling 48 of something for $3 each, or 32 of something for $3 each, how much more, or which one would make more money? What's the opposite one of this one, right? Because if this is a better deal for the students, then this one's a better deal for the store. So 4 notebooks. All right, let's turn that page. Okay, another helper in the school store suggests making packages of 7 or 8. But I guess they got like another shipment of books. So how many packages of 7 notebooks can be made from 896 notebooks? I think we will need our whiteboard for this one. So 896 divided by 7. You can have 100, it's a 700. subtract 196. Then you can have 20, which gets us 140. And then you have 56, and then you can have 8. So 128 with no remainder. So 896 divided by 7 equals 128 packages. Now you find the next one. How many packages of 8 notebooks can be made from 896? You do that one first and then check and see if you got the same thing as I did. So I'll put my 8 here. I have 1. That's 800, so 100, right? And then 96, 8 times. 8 times 10. We'll do 10. 80. And then 16, 2. And I was thinking there, isn't 8 times 12 96? And it is, because it's 8 times 10, which is 80, plus 8 times 2, which is 16, so that's 96. And that's what we did right there. 16, 0. So that's 112. So 896 divided by 8 equals 112 packages. Okay. Now this is a similar question from before. The store will sell packages of notebooks for $6 each. Would you rather buy a package with 7 notebooks or a package with 8 notebooks? Explain. Which one would you rather buy for $6? I mean, if you have like I guess a lot of need for notebooks. Probably the 8 one, right? So 8 notebooks is a better value. Now, that's not the only reason that people buy things. Sometimes they like the colors or they like the style or something like that, but this is just based on value. Would packages of 7 notebooks or packages of 8 notebooks make more money for the store? If 8 notebooks is a better value for the customer, then what would make more money for the store? 7 notebooks for the same price, right? Would be now one thing to keep in mind, if one store is selling a pack of 7 notebooks for $6 and another store is selling it for 8 notebooks for $6, a lot of the customers might shift over to the cheaper store, and then even though this might be better for the store, if no one's there buying it, it's not really better for the store. So that's something to keep in mind, a little basic economics for you. Okay, the students at Walnut Street School collected 2,790 cans for a recycling center. Each student brought in 5 cans. How many students attended the school? How do we set that up into a math problem? What do you think? If you thought we should divide 2,790 by 5, you are correct. So let's go ahead and do that. 2 can go into 27 5 times and get us 25. Subtract, bring it on down, bring it on back. Same thing, 25. Bring it on down, bring it on back. 48. No remainder. Now, if you think about it, this is the number of students. So it would be weird to have a remainder for a number of students, I think, unless there's like some kids who brought in like maybe 6 cans or something like that. That would be the reason. So 558 students. Okay. A cube can be made from 6 square cards that are each the same size. How many cubes can be made out of 7,254 cards? What do you think we should do? We have a number of cards and we're trying to break it up into equal groups of 6. So we shall divide 7,254 divided by 6. So 6 can go into 7 one time, subtract, bring it on down, bring it on back. 6 goes into 12 two times. Subtract. And then 5 0 times. So minus 0, 5, 4. Here, I forgot my arrow there. 4, 54. 6 goes into 54 9 times. And it's 54, and there's no remainder. So 1,209. 1,209 cubes. All right, last one. See if you can do it before I do. You ready? There are 5,896 beads in a barrel at a factory. These beads will be sold in packets of 4. How many full packets can be made from the beads in the barrel? What shall we do? Shall we divide these beads into bags? I think so. Or packets, I guess. Would have been more of a tongue twister if they said bags. 5,896 divided by 4. All right, that's 1. Bring that 8 down. That's 4, 16. 4 times 4 is 16. Then 2. Bring that 9 down. 4 times 7 is 28. 1. That's 6 down. 4 times what is 16? 4. No remainder. So 1,474. 1,474. Packets, full packets. Okie dokie. So, make sure you're practicing your math facts every day. Check and see if you have an assignment. I'll catch you next time. Thank you for joining me. All right, my friends. Bye-bye.